Section 1.2, Evaluating and Simplifying Algebraic Expressions. So first, some definitions. A numerical expression is simply an expression that has just numbers, operations, which would be add, subtract, multiply, and divide, and grouping symbols, which would be parentheses. A power. So 7 to the third is a power. A power is made up of a base, so that's the number that is being raised to the exponent. And so that means that we would have 7 times 7 times 7. The base is the number you're multiplying, and the 3 is the number of times you're multiplying it. One thing I want to bring your attention to is, especially when it comes to powers, is the use of parentheses. So these two problems give you two totally different answers. So this first one, -3 in parentheses squared, means -3 times -3. So the whole parenthesis is squared, which would give us a positive 9. The second one simply means it's negative, and just the 3 is squared. So negative of 3 times 3 would give us -9. Please be aware of parentheses when you're dealing with exponents, especially if you're putting them into your calculator. So next we have the order of operations, and you might be familiar with the order of operations from the phrase PEMDAS, or please excuse my dear Aunt Sally. There are basically four orders that you have to do. First of all, if there are any parentheses or grouping symbols, you must do what's inside those parentheses or grouping symbols. And so sometimes that entails, once you're in those parentheses, reevaluating the order of operations. Are there more parentheses? Are there multiple things going on inside those parentheses? Then any exponents you have to take care of. Then you're going to multiply or divide in the order that it appears from left to right. So multiplying and dividing are equal importance, so whatever they appear left to right. And then finally you're going to add or subtract again in the order that it appears from left to right. A variable. A variable is simply a letter that's used to represent one or more numbers. An algebraic expression is simply an expression that's going to involve variables, so we're going to start having letters in our expressions. An example, so let's evaluate this algebraic expression. The first thing you would need to do is substitute -4 in for all the m's. And so again, we're raising m to the second power. Our m is -4. So that -4 needs to go in the parentheses. So there we would have just substituting things in. Then we're going to look at our order of operations. We have parentheses, but there's nothing going on in the parentheses. There's just a single number. So then exponents, -4 squared would give us 16, and I just rewrote the whole rest of the problem. And then we're going to, there is no division, so we're going to multiply 3 times 16 and 5 times -4. And finally, we're going to add 48 and -20 and -12 or -12 and get 16. The second example, again, we're just going to substitute the 6 in for the values. But again, now when we look at the parentheses, and in the second step, I changed them to brackets just so we could kind of see the difference between the sets of parentheses. So now in those brackets, or in the bigger set of parentheses, we have multiplication and subtraction. So we had to take care of the multiplication first. We still have something going on in the parentheses, so now we need to do that subtraction. And now we have that exponent, so 3 to the third is 27. And finally our multiplication, so 48 plus 27 would give us a final answer of 75. Moving on, terms are parts of an expression that are added together. So in this expression, 3x squared plus 5x minus 7, we have three terms. We have 3x squared, we have 5x, and we have a -7. So remember that their terms are added together. A coefficient is the number part of a variable term. So if there's a variable, then the coefficient is the number part of it. So how many x squareds do we have? The coefficient is 3. How many x's do we have? The coefficient is 5. Like terms have exactly the same variable parts. So they have the exact same variables raised to the exact same power. So if you have an xy and you have an x squared y, those aren't like terms, because though they both have x's, one of them has an x squared. If we want to simplify an expression, An expression is considered simplified when there are no grouping symbols and all like terms have been combined. So let's do a couple quick examples. First of all, my like terms are the r to the third. So 8r to the third minus 9r to the third is going to give us a -1, or just negative r to the third, and there's nothing to combine with the 6r squared. This example we have to distribute first. Remember we distributed yesterday? When we distribute first, 9 times t is 9t minus 36. And then be careful, in that second set of parentheses, you're actually distributing a -6. So -6 times t would give us you a -6. -6 times 7 gives you a -42. Combining like terms, 9t minus 6t is a like term, so 3t. And then minus 36 minus 42 gives you a minus 78. You're selling fresh squeezed lemonade at a county fair for $2.50 a glass. You spend $180 to rent the stand and buy the ingredients. Write an expression that shows your profit. So we have sales minus expenses. The price per glass times the number of glasses is going to be our sales, minus the rent and ingredients. So $2.50 per glass times G, the number of glasses, minus 180. Find the profit if you sell 268 glasses. So we're just going to substitute 268 in for the G, and we're going to simplify that to $490. We sold 60 DVDs. Brand A is $15 each, and Brand B sells for $12 each. Write and simplify an expression. So there's a couple of ways to do this. First of all, the price per A times the number of A that you sell, and price per B times the number of B that we sold is in general what we're trying to do. So the price for A is 15, and the number of A that we sold is going to be X, because we don't know. The price per B is 12, and the number of B, well, we can't use X again because that would mean we would sell the exact same number, so we have to use a different variable. And if we do this, we need to make sure that we also show that the number of A and the number of B together equals 60 DVDs. We could also do this, if we solve that second equation for y, subtracting the x to the other side, we would get 15x plus 12 times 60 minus x. And now when we distribute, we could either distribute, or during the second part of the problem, if the total income, if 38 of the 60 DVDs were brand A. So because we're told that we have the brand A, that's why I would use this, the second expression that we have, because then I can just substitute the 38 in. If we use the 15x minus plus the 12y, we would just have to figure out if there were 38 of kind A, how many would there have been of kind B? If you have any questions, please make sure that you come to class and ask them, or refer to the longer video that is also posted that has a little bit more explanation and a few more examples in it.